For this last video, we're just going to do a couple of homework problems just to show you how to be able to graph these and have that available for you to be able to do a couple of different problems. Then you'll have some homework problems that you'll have to do on your own as well. So even though I do these in class, does not mean that they are not due on the homework. So you need to actually do them. Okay, so we have now one with a fraction. Anytime we're working with fractions, the easiest way to do it, find a common denominator, multiply everything by that denominator. So notice that this 3 will cancel, so I have 2x. This 3 will cancel, so I have minus 10 greater than, and then 3 times negative 4 is 12. So we distribute it to all of the terms. Okay, that's important. You have to distribute it to all the terms. Okay, so I have 2x minus 10 greater than or equal to 12. So I'm going to add 10 to both sides. So I get 2x is greater than negative 2. When I add those two up, I get negative 2. I'm going to divide by 2. So I get x is greater than negative 1. So here is an equation. Notice in this particular case that I only have one variable. So this is a kind of a different example now. So we're not doing two variables. We've only got one variable. So how do I graph that on a graph that has an x and a y value? So I'm going to show you how to do that now. So we have this, right? Now, how do we go and we graph that? It says x is greater than negative 1. So anytime you have a single variable in the equation, if it's an x, it's going to be a vertical line. If it's a y, then it's going to be a horizontal line. Okay, now how do I know that? Because we've taught you that already, or I've gone through that already in previous sections. So in previous sections, when we had y equals negative, or x equals negative 1, then all we would do is find negative 1, and we would draw a line there, okay, a vertical line there. We're going to do kind of the same thing now. Notice that we have a negative 1, and notice we don't have an equal sign there. So since we don't have an equal sign, based on what I've been talking about, then it has to be a dashed line instead of a solid line. And then it says greater than. So which way is greater than? Greater than. Notice I don't even have to plug any numbers in. So greater than is going to be to the right. Okay, pretty straightforward to be able to graph that one. Okay, then I'm going to do one more homework problem. So now I have y plus x is greater than 3. And by the way, this was an example problem. Notice there's only a y there. So what's this going to look like? I'll just at least write it down. That's going to be a horizontal line. Okay, so now we have y plus x is greater than 3. So now I'm going to do it a little different way. I'm going to find it using the intercepts. So I'm going to set y equal to 0. So I'm going to plug in 0 there. So I'm going to say 0 plus x is greater than 3. So x is greater than 3. So what that tells me is that 3 is my, in this particular case, my x-intercept. That's because I set y to 0. I'm going to set x to 0 next, and then I'm going to do y plus 0 is greater than 3. So y is greater than 3, so that means that in the second case, I have 0, 3. In the first case, I have 3, 0. So now it's a little easier to graph if you do it that way. That's a different way again. Notice 3, 0, 1, 2, 3 would be right here. That point is 3, 0. And then 0, 3, 1, 2, 3 would be right here. So that is 0, 3. Notice in this case it is a does not have an equal sign, so it's going to be a dash line. So it's going to be a dash line. And then we have to figure out does 0, 0 fall in that. Now we do the same thing. Notice that 0, 0 is not part of the line, so we're going to plug it into the original equation. So I have 0 plus 0 is greater than 3. 0 is greater than 3. Is that true or false? It's false. Therefore, 0, 0 is not part of the plane, so the plane is going to be drawn on that side. And that's how we go through and do graphing of inequalities with two variables, or in some cases with a single variable. We can see how to do that. Notice what we have in all of these cases. Okay, that's the end of 6.5.